Hello students, today I will explain you what is the formula for electrical field due to a single charge, which is also known as source charge. So this is the charge which has created a field all around it. Field means a region in which other charges, if they will try to enter, they will experience something. For example, if I want to keep another charge, a tiny charge q naught, which is also known as test charge, a small tiny charge, okay, let me consider that source charge is positive, okay, and the test charge that I want to keep is also positive. So don't you feel all around it, the source charge, there is a region that the moment this will enter, it will try to repel it will kick out, right? This source charge will say, why are you coming in my region, right? This source charge has created a region all around it in which others are not allowed. It has made its own territory, okay, and in scientific word this territory is known as electrical field, where other charges are not allowed. To measure the intensity of this field, this region created, we use a word which is called electric field intensity, okay, and in short we just call it electric field. I hope you understood. What is electric field? A region around it in which other charges experience force. Means if they are positive, they will be thrown out, right? They will feel repulsive force. If they are negative charges, they will they will experience attractive force by this source, correct? Now, we will understand the intensity of this field. So, from there we know the basic formula, the force experienced between two charges q1 and q2 is this. This is Coulomb's formula. We all know that, right? So this is Coulomb's formula. It says force, electrical force between two charges q1 and q2 separated by a distances r is this, okay? Suppose the distance between these two charges is r here, correct? So I have taken q1, the first charge is q, and q2 is q naught, correct? q2 is q naught. So what is the force between these two charges? These two is nothing but q into q naught by r square. Now from basic definition, the electric field intensity for any region is known as force per unit charge. Okay, the intensity of field is defined as force per unit charge. And what is this charge? This is not the source charge. This charge has to be the test charge. Test charge means the charge which is experiencing force. Okay, if among these two charges, which is experiencing force is q naught, not the source. Source is creating the field. Okay, so in this definition, electric field intensity is force by charge, where charge is the test charge. Okay, so we know this in this formula. Can I bring this q naught here? It's like this. So F, this is the force, divided by q naught. What I did here is this q naught I am bringing here. So F by q naught, what is left over here is kq by r square, right? I am writing here kq by r square. F by q naught is kq by r square. And this is nothing but electric field intensity by definition, correct? So let me see here. So electric field intensity is kq by r square. In subsequent part of the chapter, we will simply call it electric field. Instead of calling it electric field intensity, we will just call it electric field. Fine. So this is the formula. What is K here? K is 1 by 4 pi epsilon naught. This is a constant. What is the Q? Q is the charge which is experiencing the force. This is the charge. And R is the distance from source charge. This is the distance from source charge. So this is the electric field intensity, which depends on the charge which is experienced I'm sorry, this is the source charge, because this is field is created by the source. So it depends on the quantity of the charge source and the distance from the source. Now we will see the unit of electric field. The unit of electric field is Newton per Coulomb. Why? Because electric field is defined as nothing but force per unit charge. So from this basic definition, electric field is Newton per Coulomb. So this was the formula for a electric field intensity to a single charge. See you in next video. Bye everyone.